At first, I thought this problem would need dynamic programming, and that scared me a little bit. But I was so glad to figure out that it can be solved efficiently using the greedy approach. So let us see what we can do about it. Hello friends, welcome back to my channel. First, I will go over the problem statement and I will try to create a diagram that simplifies the problem so much for you. We will go over a brute force approach and then try to understand how a greedy approach can give you the efficient solution so quickly. We will also do a dry run of the code so that you can visualize how all of this is actually working in action. Without further ado, let's get started. First of all, let us try to make sure that we understand the problem statement correctly. There are a lot of words, so I will try to convert them into diagrams since they stick in your mind forever. Over here, the main idea is that you are given certain gas stations. For example, over here I have 5 gas stations, and all of these gas stations are organized in a loop. What you need to do is you have your car and you have to travel all of these gas stations. For each of these gas stations, you are given 2 parameters. This first array tells you how much amount of gas is available at each of the gas station. So this is telling me that I have one quantity of gas available at the first gas station. It could be 1 liter, 1 gallon, anything. You are not concerned about it. All you need to know is that at the first gas station, you have 1 gas available. And I'm representing the gas available with this particular symbol. For the second station, you have 2 gas available, then 3, then 4, and then a 5. The main idea is this is the order in which you will have all of these gas stations. Notice that the position of car hasn't been determined yet. The next information that you're given is the cost involved at each of these gas stations to go from one station to another. What does this mean? For example, take a look at this particular value. So it is telling me that for this particular station, if I have to go to gas station number 2, it will take me a cost of 3. What it simply means is, if I have my car over here, then to go from station 1 to station 2, I will need 3 quantities of gas. Right now, my gas tank is empty. I don't have any gas available. At this station, I can only fill 1 gas, right? So if I'm starting at this particular station, I can't even go to gas station number 2. Forget about completing the entire loop, correct? So this information is available for all of the gas stations. I have represented the cost required to travel to the next gas station with this particular symbol, right? Now, what do you need to do? You need to pick up a starting point for your car. You will have to start at some point or the other, right? And then go in the loop. You have to determine a position such that when you start from this particular gas station, you are able to complete this entire loop. For example, in this particular test case, if I start my car at this particular position, this is index 3 because array has 0-based indexing. Notice what happens now. At this particular position, my current gas is 0, right? So what I can do over here, I can fill up my gas tank with 4 quantity, right? So currently my gas available is 4. And now if I have to move to the next station, how much gas will I consume? I will consume 1. So now what do I have? I have 4 minus 1, and that means I have 3 gas available. Once I'm at this station, what can I do? I can fill up 5 gas more. So I'm at this station now. I fill up 5 gas more, and now I have a total gas of 8. What do I do now? I have to now travel to the next station. To make this move, how much gas do I need? I need 2 gas. So when my car moves over here, I had 8 gas, I consume 2, that means I have 6 available. And at this station, I can add 1 gas to my tank. So I add 1 and then I get 7. At this particular station, I have 7 gas available. Now I have to move to the next station. And how much gas will I need? I will need 3 gas. That means 7 minus 3, and that is 4. I have reached this particular station. And at this station, I can fill up 2 additional gas. So I do 4 plus 2, and that gives me a 6. And now is the time to travel to the next station. I travel to the next station and I had 6 gas available. To move over here, I need 4 more gas. So I will do 6 minus 4, and that gives me a 2. I can fill up 3 more gas. So I do 2 plus 3, and that gives me a 5. Up till this location, I will now have 5 gas available. And what is the next step that's remaining? I just need to move to the same station again. And how much gas do I need? I need 5 gas. And I have 5 available. So 5 minus 5 is once again 0. And I will land at my starting index. So for this particular test case, I can safely say that if I start at this particular index, then I can make the entire loop. This is in fact possible. So if you are able to make this entire loop, you need to return this index. That is why 3 is your answer. But if in any case you aren't able to make this complete loop, then you need to return -1 as your answer. This was the case when you have a valid scenario. What about when this loop is not possible? For example, take a look at this particular test case. Notice the gases I have available, 1, 2, and 3. So I can mark it at each of the stations. And what is the cost to go to the next stations? They are 3, 4, and 5. So I need to mark them also. What do you notice over here? No matter which station you start at, the gas available to you is less than the cost required to move to the next gas station. You have 1 gas available, but you need 3. So this is not possible. You have 2 gas available, but you need 4. So this is also not possible. You have 3 gas available, but you need 5. So this is also not possible. Clearly, no matter wherever you start, you cannot form a loop. So for this kind of test cases, you need to return -1 as your answer. Notice that it could be possible that you can make a move to one of the gas stations, but then you will have to stop because you ran out of gas. So somehow you need to come up with a solution that you're able to determine that yes, I can form a complete loop, and then where do you want to actually start? The problem guarantees that there will be only a unique solution possible. It won't be possible that you can start at multiple locations. These are the problem constraints. So you just have to determine if a loop is possible or not. If yes, you need to tell me the index. Otherwise, you need to return -1. I hope looking at this diagram simplifies things more for you. If you feel that it is now much more clear, feel free to stop the video right over here and attack the problem once again on your own. Otherwise, let us dive into the solution. Before you dive into the solution, you need to tackle one critical part about the problem. That is the loop even possible or not? And if you think about it, it is very, very simple to determine. For example, look at both of these test cases available over here. Over here, I am calculating what is the total gas available to me. And these values help me to determine the total cost to move through my loop. So what I can do is I can calculate all of this by adding them up, and then I can add all the total cost also. When I do that, I will get two values. The total gas available is 15 and the total cost is also 15, correct? This is telling me that yes, this trip is possible because you have equal gas available that is allowed to make your complete trip. And similarly, look at this test case also. What is the total amount of gas that is available to you? That is 3 plus 3, 6 plus 2, 8. And what is the total cost needed? That is 4 plus 5, 9, 9 plus 3, 12. So what is this telling you? No matter what position do you start at, if the total cost is greater than the total gas available, you can simply return a -1. This is the first step that you need to do even before you start to attack your problem. Because think about it. If you don't even have the gas required, how will you complete the trip? You don't have to even bother about, okay, I need to start from which of the positions. So when you're writing the solution, this is the first thing that you need to do. Determine if the loop is even possible or not. If not, simply return a -1 and then you can exit out. Otherwise, let us now try to calculate what is the best starting position. Let us take up the test case that we initially had. Over here, what is the most naive solution that comes to your mind? The brute force way to solve this problem will be that, okay, you will try to form a loop by starting at each of the indexes. For example, if you try to start at this particular index, how much gas do you have? Currently you have 0. You try to add 1 and then you will need 3 more gas. This is negative. So this position is not even possible at all. What you can now do is you will now try to iterate over the next position and then try to do the same calculation. Or you can also go randomly to any of the indexes and try to form a loop. For example, try to look at this particular position. I have 5 gas available and then I will consume 2. So I will have 3 gas remaining when I arrive at this particular position. For this position, I will add up 1 gas, so I have 4, and then minus 3 to go to the next destination. I move over here and I have 1 gas available. Now what happens? 1 plus 2, I get a 3, and then I need 4 gas to move to the next destination. Minus 4, and that is negative. As soon as you see something is negative, you can stop over there because it is not possible, and this index also did not work out for us. What you will now do is again try your car from any other index and try to form the loop. This is how the brute force solution works. And yes, you will find out the answer, but it will have a time complexity of order of n square. You will have to start from each of the indexes and try to form a loop. What is the efficient approach over here? And that will help us to determine our greed criteria. Think about it. You have already determined if a solution to this problem exists or not. You know that, okay, the total gas I have available is 15 and the total cost is also 15. It is damn sure that a solution to this problem will definitely exist. You just need to find out the starting index, correct? So you can do one thing. You can iterate over each of the indexes and then try to start from over there. So try to think, can you start from this particular index? The gas available is 1 and the cost is 3. So this is negative. It means you cannot even start from this index. You can simply discard it. Now what do? You go over to your next index and try to see, can I start from over here? The starting cost is 2 and then you need 4 gas. This is again negative, so you can discard it. Go to the next index now. The starting gas is 3 and you need 5 more. This is again negative and you can discard this also. What are we doing over here? Our greed criteria is, can we even start from the position and are we able to reach at the very end? So look at this next position now. My total gas available is 4, correct? So I start from 4 and then I will consume 1 gas. That means I have 3 gas available. Now move on to the next index. It is possible that, okay, this might be a candidate for our answer, but we still need to check. So now go to the next index. I had 3 gas available and then I filled up with 5. So now I have a total of 8. And how much will I consume? I will consume 2 more. So I do 8 minus 2 and that gives me a 6. What happens now? You have reached the end of the loop, but you do not need to look for all of these values again. You don't have to complete your loop. Why? Because you have reached the end and you saw that you have a positive value for your remaining fuel. And it simply means that this solution is possible. Why? Because we have already determined it. And if I am able to start from this position and I reach the very end with a positive fuel, it means the solution exists. And this is the starting index. So for this particular test case, this particular index, this is your answer. So basically we did 2 things. First of all, determine if a solution is even possible or not. If yes, we need to apply our greed criteria. Can we start from a particular position? If yes, we need to evaluate if we can go to the very end. If not, we discard it and then we will look for another position. If this is still not clear to you, let me show you one more example and then I guess it will become super clear. This test case is slightly modified. And once again, what is the first thing that you do? First of all, find out the total gas that you have available. 18 is more than 15. It simply means that yes, this trip or this loop is completely possible. All you need to determine is where to start. Starting with a greedy approach, what do? We start at this first index. I am at my gas station and I will try to check, hey, can I start from this particular position? My current gas is 0. So I fill up with 4 amount of gas and then I consume 3. I have 1 gas remaining and then I can move on to my next gas station. Notice that we do not discard this over here. We are considering it. Move on to the next gas station. What happens over here? I had 1 gas available. I will add 2 more. So now I have 3 gas. And then how much do I need to go to the next station? That is 4. So 3 minus 4 is minus 1. This is negative. It simply means that if I started from over here, I cannot continue my journey. So what will we do? We will discard this. And by discarding, what do you mean? It means that you discard all of the values that you had initially considered. So now you no longer want this also as your starting candidate. Because if you started from over here, you cannot continue your journey, right? So all I need to do is I will again reset my gas tank to 0 and I will move my car to the next available position. Notice that I was trying to carry over this value. But if I determine that the fuel is negative, I will reset this value back to 0. And then once again, I will apply my greedy approach. I have 0 gas right now. So I fill up 3 and I need 5 more. This is again negative. So I will discard it again. When I discard it, what do I mean? My gas is again at 0. So I start from over here. I try to fill up gas 4. I need 1 to consume and that gives me 3. If I have a positive value, move to the next gas station and carry over whatever gas I had remaining. I have 3 over here, so 3 plus 5 is 8, and then I consume 2. This leaves me with 6. My loop has ended and I have a positive value at the very end. It again means that this journey is possible. And where did I start? I started at over here. So all you are doing is keeping a track of the starting index and you update it as soon as you get a negative value. Let us quickly do a dry run of the code also so it becomes even more clear. On the left side of your screen, you will have the complete code to implement this solution. And on the right, I have my input arrays, the gas and the cost, which are passed in as an input parameter to the function CANCompleteCircuit. And to begin our code, what do we do? First of all, we initialize our total gas and the total cost. So we go through a for loop and add up all of these values. Once I add that up, I try to determine is this journey even possible or not. If I find that the total gas is less than the total cost, then I cannot even continue my journey. So I simply return a -1. So far so good. Whatever I will have at the bottom, I know for sure that the solution exists, correct? Now is the time to determine, okay, what is the starting index? And here is where we will be greedy. We have our starting index as 0. And that is my current assumption. I assume that, okay, from here, I will be able to complete my journey. But now I need to check. So what do I check? Am I able to go to the next station from this particular position? So I try to find out this gas at I minus cost at I. So 1 minus 3, this is negative, right? If this is negative, it simply means that the journey cannot be started from this particular position. So what I do is I do start index as I plus 1. That means I did not have to start from this position. Instead, I will want to start from this particular position. And I also have to reset things. That means I reset my current gas to 0. Once again, this loop will run and I will try to find out, is this a good candidate? No. So I will go to the next position. This is also not a good candidate because 3 minus 5 is negative. So I will go over here. What happens at this position? I once again do gas at I minus cost at I. So 4 minus 1 and that is 3. This is positive. And I am storing, okay, this is the current gas that I have. So don't do anything in the loop. And notice my starting position is over where? This is the index. Now, when this loop runs again, what will happen? I is pointing at this particular position. So I will try to find current gas plus whatever I had and then gas at I minus cost at I. So 5 minus 2 and that will give me 3. I add this to my current gas. My current gas is still positive. So it means I am able to complete my journey and my loop has ended. So what do? I exit out of this loop and I will return my starting index. This was the starting index. So you see, we just did one iteration of the entire array and that gives me a time complexity of order of n because you're iterating only once. And what's the space complexity? We do not take any extra space and hence the space complexity of this solution is order of 1. I hope the problem statement and the solution are now pretty much clear to you. Personally, I have found this problem when I appeared for Google coding interview. And Google is notoriously famous for this. They will ask you a problem which feels very complex And you will think about, okay, I need to apply graph or dynamic programming or something very complex. But the solution lies within the details. So it is always a good idea. Just try to plot it out, try to draw it, and then go over it case by case. Think about it. If you are looking at the gas and cost, some things can be easily eliminated out, and that can drive you towards an efficient solution. So, something to keep in mind whenever you're appearing for your coding interviews. While going throughout this video, did you face any problems? Or do you have any other method in mind which can solve this problem even more efficiently? Just tell me everything in the comment section below and I would be happy to discuss all of it. As a reminder, if you found this video helpful, please do consider subscribing to my channel and share this video with your friends. This really keeps me motivated and I can make more such videos. Also, a huge shout out to all of the members who support my channel. You guys really keep me going. And as a member, you do get priority reply to your comments and early access to new videos as well. Stay tuned for my upcoming video. Until then, see ya.